So, good afternoon, everyone. Dear all, I am Niranjan Pendarkar. I am senior staff at Nutanix. However, I'm not representing Nutanix. I am in fact wearing a SNIA hat to give you an update on persistent memory, where we are, what is the latest in persistent memory. So the persistent memory initiative, it fits under what is called as CMSI, Compute Memory Storage Initiative of SNIA. So all the leading companies of the SNIA Compute Memories and Storage Initiative, CMSI, that's what we call it, support the industry drive to combine processing with memory and storage, and to create new compute architectures and software to analyze and exploit the explosion of data created over the next decade. The CMSI and its special interest groups. There are 3 special interest groups, specifically computational storage, persistent memory, solid state form factors, and performance. So these educate and engage different people. Then it also accelerates standards, which includes architecture and programming specifications, then architecture and application specifications, and also some of the joint activities with other alliances, let's say with NVM Express, JEDEC, and things like that. It also propels technology adoption through SNIA webcasts or video libraries, or let's say presentations and networking at virtual and physical events, and developer education through tutorials, etc. So this is the largest initiative within SNIA in terms of member companies, form factors, architectures, and things like that. You can know more details about CMSI initiative through the link that is given below in this slide. So what are the opportunities to participate in CMSI? So CMSI is always looking for new members. Whether you are interested in computational storage, solid state disks, or persistent memory, we have a variety of technology and marketing work where you can participate. View our resources in the educational library or watch our weekend video series. And SNIA wants everyone to participate in this. So I have been personally involved in integrating persistent memory solution into our product, and have been interacting with a lot of architects who are involved in this initiative. So I can share my own personal experience. It has been a very, very fulfilling experience working closely with the SNIA members. In fact, I have personally learned a lot through this interaction, and this is still a work in progress. So there is a lot to learn. So I'm very excited about it. So with citing my personal example, I would urge everyone to consider participating in some of the initiatives of CMSI. Now, after talking about CMSI, let's dive deeper into a particular group which deals with persistent memory. So let's talk about what is persistent memory. So persistent memory has 2 words, persistent and memory. So persistent memory is non-volatile, which comes from the persistent part, which means that after power cycle, we don't lose its contents. It is byte addressable. So that's the memory part. We can do load and store into it. We don't have to do I/O using block sizes. Then it has low latency, comparable to that of memory, DRAM. And it also has densities, which are equal to or greater than DRAM, the dynamic random access memory. It is beneficial because it can dramatically increase system performance, then enable a fundamental change in computing architecture. Applications, middleware, and operating systems, they are no longer bound by the file system overhead in order to run persistent transactions. And there are varieties of technologies that are available that can give us persistent memory. So if you look at the bottom left corner of this slide, talks about varieties of technologies. that are available. So some of them meet JEDEC standards, some of them are proprietary technologies, and some are emerging technologies. But all have the potential to be used as persistent memory by complying to the existing SNIA programming and technical models. So that's the beauty of this SNIA programming and technical model, which we'll talk in the later slides, that it is agnostic to the underlying technology of implementing the persistent memory. So when an application complies with this model or uses the programming model that is described here, then irrespective of the underlying persistent memory technology, the application will work well. Now, coming to the middle portion of the slide, we can see that there is a nice pyramid there, and it basically has all the storage technologies that we have today. Now, it has been arranged in terms of latencies. So the topmost part of the pyramid is, of course, CPU. Then there are these L1, L2, L3 caches of CPU. Then the DRAM, which is of the order of tens or lower hundreds of nanoseconds. Then comes the persistent memory. The latencies there are like some multiples of 100 nanoseconds. Then comes the performance SSD, where the latencies are of the order of 10 microseconds. Then comes the capacity SSD, where the latencies are of the order of 100 microseconds. And then lastly comes the HDD, hard disk drive. And we know that the latencies are of the order of few milliseconds. So as you see this pyramid, as you go from bottom to the top of the pyramid, you can see how the latencies start improving. On the rightmost part of the slide, there is some comparison given in human observable terms. So if NVDIMM DRAM is equivalent to kind of sending kind of email or something like that in seconds, then the HDD latencies correspondingly in that scale come to about weeks of walking. So that's just for comparison purpose, by the way. So we can see how persistent memory wonderfully fits in the gap between DRAM and the performance SSD. So to enable this persistent memory technology, the innovation is required at all levels in the stack. So if you look at the top left corner of this slide, here we're talking about innovation in the operating system that has been done in order to consume persistent memory or leverage persistent memory. So changes have been made in Linux as well as Windows operating system. And some applications themselves have also changed in order to leverage persistent memory. Now, at the bottom left corner of the slide, you can see various hardware technologies implementing the persistent memory. And then top right are the standards where we had to incorporate persistent memory. And the bottom right corner are the hardware platforms that have to adopt to this technology. So we are also working with on future technologies in conjunction with other industry bodies as well. But much of this SNIA's work is in the area of application and software enabling. And we'll continue to advance operating system and VM support for persistent memory while we encourage developers, large and small, to support persistent memory. So the SNIA persistent memory activities cross much of the CMSI initiative. We support a variety of technology work groups in programming and solid state storage. Much of the work is delivered via the marketing SIG. And we'll talk about marketing SIG in a couple of slides from now, where we look for innovative solutions that can highlight this. SNIA runs a hackathon workshop program, including a virtual hackathon. So we were supposed to be running virtual hackathon this week in this SDC as well, but unfortunately we have not been able to do that. So apologies for that. But if you have interest in doing something more with persistent memory, We are always interested in more participation. So look out for hackathons, future hackathon events, and get involved. These programs allow people to get hands-on access to the code. So SNIA wants to build standards and also deliver them in a very friendly way. So let's talk about the SNIA persistent memory programming technical work group. As I said, the heart of SNIA work is the persistent memory programming model that is developed in NVM TWG. TWG is Technology Working Group. We have built a cross-OS VM model that can be used to address persistent memory in a variety of ways. A persistent memory is delivered in different form factors. We continue to build extensions to this model that will enable applications to seamlessly move from system to system. So this is an example of what an industry body can do. I've been personally involved in this, in using this programming model and trying to integrate persistent memory into our product. And there has been a great help in leveraging this persistent memory. This programming model has been a great help in leveraging persistent memory in our product. We are receiving all help required to make this integration possible. I'm also aware that all the participating companies are continuing to contribute more to this effort to evolve this programming model. So through this model, persistent memory can be made available as a block device or through a file system interface, existing file system interface, or as a memory using load and store instructions. Depending on how best application can leverage persistent memory, a particular model can be used. There are different libraries that have been made available to consume persistent memory so that the simple things are taken care of. The details of persistent memory in order to leverage it specific to a platform, they're all taken care of, and we can focus on leveraging persistent memory for the application we are working on. So this is a great help. This programming model is a great help in leveraging and consuming persistent memory. The next steps are also being taken in this technology working group. For example, to create a model for accessing remote persistent memory. Now, why does one need to access remote persistent memory? Specifically for high availability reason. So that model is also being developed. Also persistent memory over CXL bus. That is also being worked on as next steps. So let's talk about the SIG now. The SIG is our marketing arm, and we deliver on a variety of topics such as education, for example, on types and benefits and value of integration of persistent memories, or to communicate the usage of this programming model to simplify the system integration. Then influence and collaborate with middleware and application vendors. Case studies, develop case studies, then best practices. Also coordinate with industry standard groups and synchronize and communicate a common persistent memory taxonomy. So these are all the things that marketing arm is constantly working on. Now, I would like you to focus on this picture on the right-hand side of the slide. This picture, you can see, has two non-volatile memory modules, two NVDIMMs. Interestingly, these two NVDIMMs are from two different vendors. And we could ship them in a single system only due to standardization, such as this. So this is the benefit of standardization. So this year 2020 has been an amazing year, a great year. And TWG continues to deliver new programming specification. We have delivered hardware thread model for persistent memory in this year. Also, a white paper on remote access of persistent memory for high availability reasons. We just talked about it. Also, a white paper on atomics and transactions on persistent memory. We also held a persistent memory summit in January 2020. And for 2021, we will be taking the summit virtual in April. So watch out for the summit in April 2021 on persistent memory. We are also additionally taking our workshop programs virtual so that global industry can get more and more access to persistent memory programming and technology. There are boot camps being done, workshops being done. So what about now? Hackathons continue. We are not done with hackathons. We are not done with challenges. We might even do some focused ones with the NVMW, which is the Non-Volatile Memories Workshop, and also the PIRL, which is Persistent Programming in Real Life teams. And of course, you don't have to wait for that. You can host your own hackathon and we help you. So NVMW, the Non-Volatile Memories Workshop, and the PIRL, Persistent Programming in Real Life, they'll continue and grow on their own. Expect to see us doing more at FMS, which is the Flash Memory Summit, and of course, SDC like this, and plenty of other places that SNIA has an influence. And of course, this process will continue to offer new programs. We are already blending in the workload analysis tools, and we also expect that the computational storage, as it grows, will also pick up similar methods. And we have a variety of resources that you can access. So follow us on the website resources or the Twitter handles or a blog for more information. And please look at all the resources for CMSI to see where you can get involved. So you can go to the web page. Twitter handles are there, YouTube videos are there, and also the educational library, SNIA educational library is there to understand more about CMSI and to decide where you can get involved in this initiative. And of course, this has just been an overview of where we are with respect to persistent memory. For more information about persistent memory, please check out our videos or visit us at our webpage. Don't forget to follow us on Twitter and check out our blog as well. So with this, I've come to an end of my update on persistent memory. Thanks for watching. Thank you. Bye.